Here's a quick presentation on VLANs and trunking. When you have devices like PCs hooked up to a switch, by default, all switch ports are in the default VLAN or VLAN 1. So at that point, you have one VLAN, you have one broadcast domain. So right now, switch ports Fast Ethernet 1, 2, 3, and 4 are all in VLAN 1. So all of these devices are in the same broadcast domain or the same network. Also, being in the same network, you probably want to address these devices in the same network with the same network prefix. So in this case, all devices have a 192.168.0 network prefix, and this is host 1, host 2, host 3, and host 4. Now you don't have to address every device in the same network, but why wouldn't you want to? Because probably the goal is to communicate between the devices. If you want to segment the network into multiple broadcast domains, you can create VLANs, additional VLANs beyond the default VLANs. So in this case, we have two VLANs, so we have two broadcast domains. We've put ports F0/1 and F0/2 in VLAN 1, and we've put ports F0/3 and switch port F0/4 in VLAN 2. Now notice both devices can still have their same IP addressing with a network prefix of 192.168.0 and 192.168.0, and you can see these two devices have the same. However, they're in separate networks now. So typically when you have two separate networks, you probably change the addressing to match the VLAN. So in this case, maybe we'd want these devices on a 192.168.2 network, because they're in VLAN 2. And then maybe these devices could stay in 192.168.0 and 192.168.0. The number of the network, like 192.168.2, does not need to match the VLAN number. It's up to you. It's logical addressing. You can choose what it is. However, we have two separate broadcast domains, two separate networks, by segmenting the network and putting some switch ports in one VLAN and some switch ports in another. Now, what about trunking? In this scenario, switch ports in VLAN 10 can only carry traffic to and from other switch ports in VLAN 10. So host A here, signified by the blue, is in VLAN 10. That means this switch port has been configured for VLAN 10. So it can only talk to other switch ports that are similarly in VLAN 10. So you can see port F0/4 on this switch has been configured in VLAN 10. So A can communicate with C, and that communication will go over the trunk. And the trunk is designed to carry multiple VLANs. It can carry packets from both VLAN 10 and VLAN 20. But host B can only talk to host D, and host A can only talk to host C. So PCA sends a packet to PCC, there's the packet. It's trying to communicate from A to C. When the packet crosses the trunk right here, the trunk, it is tagged with a VLAN 10 ID. So this switch will tag that packet with a VLAN 10 ID using the 802.1q protocol. Now when that packet crosses the trunk, it has an identifier in it that says I'm part of VLAN 10. So when the switch picks up the packet over here, or when the packet is received at the other end of the trunk, the VLAN tag is removed and it is forwarded to a switch port in VLAN 10. So it could only go to another switch port that's also in a similar VLAN, VLAN 10. Why? Because it had a VLAN 10 tag. The trunk carries traffic from multiple VLANs by tagging packets with their respective VLAN ID numbers. So as you can see, as traffic flows across the trunk, the packets are tagged, or the frames are tagged with their respective VLAN ID numbers, thanks to the 802.1q protocol. Now, if you don't want to use a trunk, another way to do this is to have a VLAN 10 to VLAN 10 link from one switch to another, but then you're also going to need another link with another switch port with VLAN 20 to VLAN 20. So you see in this scenario, we can now communicate from A to C and B to D without a trunk because we have a link, an access link on VLAN 10, and we have an access link on VLAN 20. However, this solution uses 4 switch ports and 2 cables and starts to waste switch ports to be able to communicate from one switch to another across the VLANs. That's why a trunk is preferable, because all traffic from all VLANs can travel across a trunk. A VLAN is a broadcast domain. A VLAN is a network. If you configure switch ports for separate VLANs, then the devices on those ports belong to separate networks, or separate VLANs. This is segmenting a switch into different networks. Devices attached to switch ports in separate VLANs cannot communicate with each other without routing. So by default, if you put switch ports in separate VLANs, devices connected to those switch ports, PCs, phones, whatever it is, servers, printers, they can't talk to one another without routing. Now there's different types of VLANs. The default VLAN, all switch ports are assigned to VLAN 1 by default. The native VLAN is used for untagged traffic sent across a trunk. It's VLAN 1 by default. So the native VLAN is set to VLAN 1 by default. Once again, it's used for untagged traffic. So if you have legacy devices that somehow can go across the trunk that don't support VLAN tagging, this is what this is reserved for. Native VLAN for untagged traffic. A data VLAN is any VLAN that carries user data as opposed to control, management, or voice data. A management VLAN is a VLAN configured to carry management connection traffic. Typically, your management VLAN will be the VLAN that the device has an IP address on. So your switch has an IP address so you can management, and so that VLAN that has that IP address, that would be considered the management VLAN, because that's the VLAN that you would use to manage the device. A voice VLAN carries voice or voice over IP data, and a black hole VLAN is a VLAN to nowhere, no user data. We've already said the default VLAN is VLAN 1 by default, the native VLAN, VLAN 1 by default, the data VLAN, VLAN 1 by default, because all switch ports are in VLAN 1 to begin with, so that's going to be your data VLAN if you hook PCs or end devices up to the switch. Your management VLAN is also VLAN 1 by default, because in the default configuration of the switch, there's an interface VLAN 1 switched virtual interface, which is used for assigning a management IP address to the switch. The normal range VLANs are 1 to 1005. VLAN 1 default cannot be deleted. Interface VLAN 1, the switched virtual interface, cannot be deleted. And VLAN 1002 to 1005, token ring, and FDDI cannot be deleted. The VLANs that you create on the switch are stored in the VLAN.dat file in flash memory. Extended range VLANs go from 1006 to 4094. They're used mostly by ISPs, and the VLAN numbers that you create will be saved to the startup config file in NVRAM if you use extended range VLANs. Also, if you use extended range VLANs, you're going to need to use VTP. A little bit more about trunks. A trunk is a switch port link that can carry traffic from multiple VLANs. It uses 802.1q VLAN tagging to add and remove VLAN tags to an Ethernet frame as it crosses a trunk link. Multiple networks can travel over one trunk instead of wasting valuable ports connecting each VLAN from one switch to another. If we look at the Ethernet frame format, VLAN tagging can be inserted into the Ethernet frame right here, right after the source MAC address, and in the ether type, right as part of the ether type length field, you can see that a TPID and TCI information can be injected into the frame. Now in this case, the tag protocol identifier, which would be the ether type field, would be 0x8100, which would identify that this frame has 802.1q protocol information. Notice that the ether type field is 0800 in hex for IPv4, 0806 for ARP, and 86DD for IPv6. But if it's 8100 in hex, it's an 802.1q protocol information. Then in the tag control information, there is 12 bits reserved for the VLAN ID. And in this case, it would look something like this, 0x00A. These would be the 12 bits, 00A. And in this case, you'd have a VLAN ID of 10 because the A is 10 in hexadecimal. So the Ethernet frame size, typically you say an Ethernet frame is 1500 bytes, but it can go all the way up to 1522 bytes. If you have 802.1q or 802.1p information added in to the frame. Let's look at the configurations to configure VLANs. So basically you've got the switch here, you're in global config mode, VLAN 10 creates the VLAN, name ITS creates the name of the VLAN, then you can create another VLAN, give it a name, create another VLAN, give it a name. Control C, show VLAN and show VLAN brief to take a look at those VLANs. Then when we configure the VLAN on a switch port, we enter the switch port like interface fast Ethernet 01. We can turn it into an access port only, and then assign that access port a VLAN. So switch port access VLAN 10. We can enter a range of ports like interface range fast Ethernet 0/2-10 would mean switch ports 2 to 10, and then turn them into access ports and then assign them a VLAN. If you want to do a voice VLAN, we can use a multi-layer switching command and assign some QoS with class of service trust, and then say switch port voice VLAN 30, and this would assign this port as a voice VLAN, which would have higher priority for QoS and class of service, so that more packets, more voice packets would be able to cross and be received. When we look at configuring trunks, you can see here we go into global config mode, then we enter the interface gigabit Ethernet 0/1, and then I wanted to point out here that if you have a 3560 series switch, a multi-layer layer 3 switch, you'll have to configure the 802.1q protocol first. So you'll have to put in the command switch port trunk encapsulation .1q to set the encapsulation on the trunk as 802.1q, as opposed to the older Cisco ISL, which was also used for VLAN trunking IDs and VLAN tagging. So if you don't have a 3560 series switch, you would just use switch port mode trunk, assign it as a trunk, and then switch port trunk allowed, and then list the VLANs that you want to be allowed across your trunk. And you can specify which VLANs are allowed. So typically you go into the interface, turn it into a trunk, and then the allowed VLANs. Also, on a trunk, you may want to change the native VLAN from VLAN 1 to another VLAN. So in this case, we've gone into the gigabit 01 interface, then put in the switch port mode trunk command, and then you could also say switch port trunk native and then assign it a different VLAN than VLAN 1. So in this case, switch port trunk native VLAN 89. So now the trunk will use native VLAN 89 instead of native VLAN 1. Now DTP is the dynamic trunking protocol. You can remember when we were turning the switch port into switch port mode access or switch port mode trunk. Well, with DTP, the purpose of the dynamic trunking protocol is it's a Cisco layer 2 protocol used to dynamically negotiate a switch port into a trunk. So the default mode on Cisco switch ports is dynamic auto. So switch port mode dynamic auto, you enter the interface, and you can put in the command switch port mode dynamic auto. However, this is the default. All the switch ports are in dynamic auto mode. And what does that mean? It means that the switch port can dynamically turn into a trunk port. If one end of the link, let's say, is dynamic auto mode, and then you connect to another switch, and on that switch port, the switch port is in switch port mode trunk, then the dynamic auto side link will dynamically turn into a trunk. So this is what you use to statically configure the switch port as an access port. This is what you use to statically configure the switch port as a trunk port. And then you have two dynamic modes: dynamic auto, which can dynamically turn into a trunk port, and switch port mode dynamic desirable, which can also dynamically turn into a trunk port. If you don't want to use DTP, you can use the command switch port no negotiate to disable DTP. Notice all of these configurations were already in the interface. So we've already put in the command interfaced fast Ethernet 0/5 or interface gigabit Ethernet 0/1 or something like that. Now, how does this work, these dynamic autos and access? Well, since the default is dynamic auto, if you have a connection from one switch to another, so let's say this is one switch and it connects to another switch and they're both in dynamic auto mode, you get an access port. If you have one side is an access port and the other side on the other switch is a dynamic auto, you get an access port. If the other side is dynamic desirable, you get an access port. However, if you configure the switch port in dynamic desirable mode on both ends, dynamic desirable on one switch connected to another switch, and that switch port is in dynamic desirable, it will default to a trunk. If one switch has dynamic auto configured on one side, the default, and the other side has dynamic desirable, it'll automatically turn into a trunk. And then, obviously, if one end is an access port and it connects to any either dynamic auto or dynamic desirable, you get an access port. If one end is a trunk and you connect to the other end and it's either dynamic auto or dynamic desirable, you get a trunk. So that's basically the function of DTP. Now you may want to not negotiate that at all, and then you would turn it off. Now what about VTP, VLAN Trunking Protocol? Now VTP, I don't believe it's on the CCNA anymore with the new Cisco CCNA, but I've got this in here, so let's talk about it anyway. Let's say you've configured S1, and you configured a bunch of VLANs. You created a VLAN 10, a VLAN 20, and a VLAN 30. And then you have a new switch, S1. Well, S1 has no VLANs configured yet. With VTP, if you configure VTP on S1 and you configure VTP on S1 over here, or S2 over here, let's say, whoops, let's fix that right there, and you configure it on S2 over here, then basically what can happen is S2 can learn the VLANs from S1 and then have them basically auto-configured. In other words, you would end up with this situation where S2 has now learned the VLANs from S1, and it learned them automatically through VTP, the VLAN Trunking Protocol. Now, how does that work? Well, it's really easy to set up. VTP is a Cisco protocol used to dynamically add, remove, and change normal range VLANs across all switches in a network. VTP has the following key settings and features. The first thing you configure is a VTP domain, and then you give it a name. And then a VTP password, and then you give it a password. And then you set the mode, VTP mode, and it could be either a server, a client, or transparent. Now, if it's transparent, it doesn't really participate. It stands alone. And now, if it's a server, it can serve VLANs, and a client can receive those VLANs and learn those VLANs. So you would say maybe VTP mode server on one end, and then the other end could be a client, or it could be a server. You also have VTP version numbers. There's version 1, 2, and 3. Version 1 is the default. And then you have VTP revision numbers. Every time a switch, whether it's a server or a client, learns from another server about VLANs, or every time there's a change in VLANs, the revision number goes up. And the VTP server with the highest revision number will overwrite the VLANs in the switches with lower revision numbers. So you have to be careful that if you want to learn VLANs from one switch to another, that the revision number on the highest switch has the VLANs configured that you want. Otherwise, your VLANs could be wiped out by another switch that has a higher revision number but may have the wrong VLANs. So a VTP server can add, delete, or change VLANs on other VTP servers or VTP clients. A VTP client cannot add, delete, or change VLANs on other VTP servers or clients. It can only learn. And VTP transparent merely forwards VTP messages, but does not participate in the adding, deleting, or changing of VLANs. It has its own VLANs. It has its own separate VLANs. But it will, in VTP transparent mode, forward VTP messages to other switches that may be servers or clients, etc. Since the VTP server with the highest revision number overwrites other switches with lower revision numbers, care must be taken when adding a new switch that has VTP, that has used VTP. Okay, fair enough.